Thanks, Anna. So I have the privilege of introducing Professor Mario Herrero. Mario leads the Food System and Global Change Program at the Department of Global Development at Cornell University. His work focuses on food systems and the environment, climate mitigation and adaptation, livestock systems, true cost of food, sustainable metrics, and health and sustainable diets. Gosh, Mario, you're pretty busy. Mario is a long-standing member of the LD4D network, so we know him really well, and we're really glad to hear from him today. So if you have any questions for Mario, please put them in the Q&A, which is pretty much in the middle of your screen, and he will be able to respond to these after his presentation. So over to you, Mario.
Thanks a lot, Karen. It is a real pleasure to be here. I always enjoy the LD4D events, and I'm really astonished by the progress in terms of the membership of the network, with so many people from sub-Saharan Africa, where many of us have worked, and where we really need to keep on working to help with issues of food security and livestock development and so on. I want to share my screen. I'll run my slides from here. Let me do that so that we actually can get on with it. Can you see my screen?
Yes, we can.
Okay, and can you hear me well?
Perfect.
Okay, great. So I'll start. I was tasked with providing some insights on methane issues, data challenges, misconceptions, and solutions that we might have to really advance in the quantification and also in the implementations of solutions for mitigating methane and other greenhouse gases. So I'd like to start by just showing this graph from the recent paper of CREPA, just to put things in context. The global food system, which incorporates livestock, is responsible for between 21 and 37% of anthropogenic emissions. The CREPA report came out at 30, but if you consider different methane estimates and things and other sources, you can say between 21 and 30%. What I want to focus first is on the green in these circles. We're basically talking about 18 gigatons of greenhouse gases, of which more than 2/3 are land-based activities. And within land-based activities, we're talking about land use change and production. So this is the majority of the greenhouse gases that we're actually talking about. There's obvious differences between industrialized and low and middle income countries in terms of the composition of the pies, with industrialized countries showing a little bit more of energy emissions because of the higher transport and processing and the high use of energy in the systems, while in low and middle income countries we're really talking about production, basically farm level production dominating the sources of emissions. And this is where livestock are important, because because of the significant land footprint that it is actually responsible for. So we'll talk more about that. But just remember this: 30% of greenhouse gases. And just to put it in perspective, why is it important to work on food systems? Just look at the graph on the left first, and these are the global greenhouse gas emissions by gas. You have the huge blue component, which is carbon dioxide from fossil fuels and industrial processes. That's the big ticket item, and they're making very significant inroads in emissions reductions. But then you have CO2, methane, and nitrous oxides from the rest of the agriculturals. sector, and methane is basically, livestock and manure. And then on the right, you see what this means in terms of the mitigation importance. So, we are actually trying to help the the energy sector with the mitigation of greenhouse gases at the global level to reach the 2-degree pathway, and to even, probably the green component of natural climate solutions, which is basically the agriculture, forestry, and land use sector, would need to be a little bit bigger to get to the 1.5 degrees Celsius target that we're wanting. And what you can see here is that without the food system, without us working on livestock and on crops, etc., we won't get there. We won't get there. It's not enough to mitigate emissions from fossil fuels. The last bit needs to really come from the kinds of mitigation actions that we are interested in. And this is why this is so important. When you talk about greenhouse gas emissions from livestock, I show this slide because the picture hasn't changed very much in composition. And we're basically talking about total direct emissions following IPCC guidelines of about, about 3.6 gigatons. If you take all the LCA approach, you're talking about 5.6 to 7.5 gigatons of CO2 equivalents. And what we're talking about this is about cattle. It's 65 to 78%. Enteric methane and feed production, the land use components, super important. Those are the two main components. Methane keeps on being there as the most important, and the majority coming from mixed crop livestock systems. So that's a general picture that allows us to think, well, what do we really need to focus on here? And the recent interest in methane, the methane pledge, what Hayden Montgomery is doing with the methane hub, etc. Well, it's super well justified considering these kinds of numbers. Now let's see where the livestock sector is going. And here is, I don't tend to do big, very long demand trajectories from the 60s because they are no longer relevant. So this is, say, the last 25 years, what has happened. And if you go down to the last, if you go down to the last row, you will see the global numbers. So what is salient here is that, we've had increases in availability per capita, increases in demand, you could say, of fish, largely of milk, a little bit of eggs. Skip the meat one because we're going to split this so that you understand it better. Bovine meat has been stagnant. Bovine meat has been stagnant globally. So basically red meat, we're not consuming more red meat per capita. It's even decreasing in the majority of the places. Roughly the same is happening for sheep meat and goat meat. The increases are largely mediated by pork and poultry meat, especially. So this is something really important, So the extra effect that we observe in increases in production are mediated through the increases in human population for the cases of red meat. There is still a very large population and income effect for increasing the consumption of poultry meat, which is becoming a lot cheaper, milk and the other products, but not so for the red meats. Now, let's examine a little bit, for example, for dairy, what has happened with the supply side. This is some work that Carlos Gonzalez Fisher, I don't know if he's in the call, and myself have been working on. And these are basically the factors that have been driving emissions in dairy system. And here we're taking the last decade. So here we have the different regions, a global number, and basically there have been increases in total production everywhere, okay? Increases in total production everywhere. Yields have increased. Yields have increased in many places, in the majority of places, actually. Animals have actually, it's been a here and there, but globally, we have increased animals by about 12% in the last decade. And you can see that in some places, especially high-income countries, upper middle-income countries, have had important decreases in animal numbers. But the lower middle income and the low income countries have had very, very significant increases in animal numbers. So if you look at yields and animals, well, then you actually start thinking also about what has happened to emissions intensity. Emissions intensity have decreased by about 10% globally, but total emissions have increased by 14%. So look, basically every place has diminished emissions intensity. And this is quite neat. But you know, this change in emissions intensity does not mean that you're going to reduce total emissions. And this is a fundamental message, because you know there is this misconception that working just on emissions intensity will provide the desired benefits of mitigation that we want. It won't. It won't, because actually animal numbers play a fundamental part. So as long as we get, you know, increases in animal numbers in many places, we are not going to get down the total emissions. Yes, efficiency, we're getting there one way or another, but not in terms of total emissions. So why is this important? Just look at this as this little graph. There's production growth is still very much led by increases in animal numbers. And here you have 4 quadrants. You have the changes in animal numbers from negative changes going to increases in animal numbers, and then you have the changes in milk production from negative changes to to increases in changes. So if you look at this right-hand upper quadrant, where 64% of the animals and 55% of production and 62% of emissions are, these are countries that have actually increased yields. They've done incredible gains in increasing yields, but at the same time, they have increased animal numbers. Yields increased and animal numbers have increased. So they're not attaining net mitigation. They're just attaining improvements in emissions intensities. While where we want to be is in this sweet spot, where you actually have, this is the red quadrant, where you want to have fewer animals, but more production. And here you have, you know, places like Colombia, like Argentina, you know, Ethiopia is there one way or another, and many other countries. Many other countries are very close to not having changed animal numbers and also increased productivity. But this is important, because what we want to do is probably try to move some of these countries here to the left side to start getting the gains on emissions intensity, but also on net mitigation. If some of these countries are going to actually state in the NDCs that that's their desire, well, this is actually what would need to happen, because otherwise they won't get to their emissions commitments. And now, why is this important in terms of metrics? I want to give this quick note on methane and metrics. Simply, hang on, let me try to remove these captions here. I always get really annoyed. No, well, anyway, I couldn't. But everybody always asks me, well, why do we need to worry about methane? Especially since it's a short-lived gas. Yes, of course, it is a short-lived gas, and you can see it in these different graphs. So you get a pulse of methane, say, from an animal today, and it will actually, yeah, fade away after 12 years or something like that. But as long as that animal is here, that same pulse of methane will occur tomorrow and the day after and the day after, and so on. So, it would be, unless we remove the animals, yes, that decay function that everybody talks about will be really very significant. But at the moment, that animal's curve would be something like the lower left quadrant that we observe. And yes, relative to carbon dioxide, yeah, carbon dioxide will be actually linear because it doesn't disappear from the atmosphere. Now, but that is what we've heard before in the previous slide, is that animal numbers are increasing. Well, so as long as animal numbers are increasing, this methane curve will actually continue to increase significantly, which is your panel on the right lower part of the diagram. So here we have, emissions of methane increasing and carbon dioxide also increasing, with methane being a significantly more potent gas. So just look at the contribution. These contributions are tiny. These are 10 to the -9. Just imagine how many zeros. Despite that, just look at the differences in the orders of magnitude between carbon dioxide and methane. So this is really, really important. And, it's simply because there is a decay function, forget it. Methane is a fundamental component of mitigation in livestock systems. And as long as we keep putting more animals, and even if the animals were stayed fixed, we need to do it. It's only when animal numbers decrease that we will see an important effect here. Okay, that's also just to correct a little bit of the misconception that we get sometimes on the role of methane into the future. And then, well, we going to the solutions. We always want to make it super fancy and with all sorts of additional ingredients, supplements, etc. But to be honest, the tried and tested increases in productivity are really, really important in all of this, because they not only reduce the emissions intensity. Here you see a curve that is a typical curve of how methane per kilo of milk will come down as milk production increases. There's this enormous increase in efficiency. But and here you also see, well, where you are in terms of where Ethiopia, India, and Tanzania are in a baseline in their baseline productivity per animals, and you have roughly what the 10% of the best producers are actually obtaining. So we know that this kind of productions are feasible. We've collected data from the field, and this is what we observe. So we know that it's perfectly possible to achieve 2,500, 3,000 liters of milk per cow.
2 minutes, please, Mario.
Sorry?
2 minutes, please.
Oh, 2 minutes.
Yeah.
Wow. Okay.
It's gone quick.
I'm talking way, way too much, actually. So what we have here is, the key would be to have less of those highly productive cows that can actually increase production, increase net production, but they would decrease net emissions if we create these changes to better fed animals. Now, in terms of, we're trying to do these kinds of curves empirically with real data. And this is something, Karen, can you give me 5 instead of 2?
Okay, we won't have questions, so we'll just take them in the chat.
Okay,
Is that
so
okay?
just super quick, because I want to make this point, and I want to make this is something that the Methane Hub is trying to really remedy. This is a very nice data set that we have been using that has all the enteric methane experiments in dairy systems. And at the moment, there's like 213 experiments. There's like 800 observations here. But like all of you, you are wondering, well, look at Africa. It's sub-Saharan Africa. There's virtually no data. There's a few data points for India, for China, but many of the regions of our interest are not in these experiments. We need to keep on doing way more to be able to fill in these blanks. It's absolutely crucial, because that those relationships that I show you, you can observe them in real data points. You pick these kinds of things, you looking at the experimental data, and we want to move to creating regressions to predict methane on the basis of the real experimental data that we have. I believe that the Methane Hub is also funding and will fund a range of additional experiments for dealing with these issues. Options, we have many, and you'll see them. This is from the IPCC report, and you've seen many of these types of things to reduce enteric fermentation. More recently, what people have been focused on, there's been a lot of interest in the methane inhibitors, vaccines, low emissions breeding, seaweed, which have different abilities to reduce emissions. And again, Franco Villotto, who works with us, has looked at the impacts of some of this. Some are significant, some are not. You have here 3-NOP with an important experimental change, the lipids as well. Some of the others are have shown less real impacts. Let me not talk to this. And then, we need to also think about feed sourcing. Circularity in feed sourcing will be fundamental for achieving what we want. So alternative sources, a lot of people talk about protein for humans, but it's more likely that many of the sources out there will also work as feeds very well. And this is something that we would probably need to push. And my last slide, Karen, just to be within the 5 minutes. Data from low and middle income countries is still scarce, and we need to actually work on that. We need to collate activity data, and here I'm going to make a call for a new group that we're going to have in LD4D. It's going to be a group on feed baskets that Carlos Gonzalez will also be leading with Gareth, and to try to remedy some of this issue. We need to work a lot on the adoption of improved practice. I think that we're still working on naive economics. This is still not profitable. There's very little incentives for farmers to adopt these. There's low investment. Funding needs to increase by a factor of 10, and the private industry also needs to engage in providing incentives for farmers as they move to more commercial operations. And let me leave it there, and maybe we can have a couple of questions. Thanks a lot.